Hello and welcome. Today we're going to be talking about proofs. We're actually going to prove some stuff today. So in our section 5, we talked about what is a conjecture and that if we prove that conjecture, that is called a theorem. So we're going to be kind of proving theorems today. So our section is going to be chapter 2, section 8, and this is our final lesson of this chapter, which is probably the most difficult of all of them. So it's just going to take a lot of practice to walk through. So how can I prove segments and angles are congruent today? So we're going to show things that are going to be congruent to each other. So let's go ahead and look down here. It looks a little crazy. So we're going to be using the given information to prove that segment AB, we're going to say AB is equal to CD. That's what we're trying to prove. Now, what we're going to do is we're going to look at all of the stuff we're given. So I'm going to move this out a little bit. So we're going to be given like kind of this blank screen where we're going to have to write in a segment and then give its reason. And then we're going to be using these to click. So, and we can actually send stuff to the proof. I always kind of like starting with the given, and that's always a good thing. So we're going to click send to proof for my given. So that will auto send it to that. Or if you're doing it by hand, you're just going to say, well, AC is equal to BD. And I like to write that in my proof. Or in my picture. I know that this length is going to be equal to this length right here. So those two lengths are equal. So if this length is the same as this length, we want to prove, we're trying to end up to showing that that is true. Now, one thing that you should know, my very, very last step will always be our proof step. So like AB, our last thing should be AB equals CD. Now, I don't know how many steps it will take to get there, and you can unfortunately put that in right away, but we'll do that as our last thing. So I'm starting with this, and I'm trying to get to there. So we know that AC is BD, and my reason is going to be that it was given to us. Now, the next thing is, well, let's think about things we've learned. Well, we've learned about segment addition, so we know that this AB and BC together is this entire length here. So I'm going to just write that down. So the entire length, which was AC. So I'm going to start and write AC. Let's do that in orange to match the color. So let's do AC is equal to that green part, AB plus BC. Now, the justification of that, you click the reason, and that will be called a segment addition. So there should be a filled in segment addition button you can click after you click the reason. Or in a proof by hand, we just write it down. Now, we're going to actually do something very similar. Just like we did yesterday, we started with segment addition twice. I'm going to do the same thing here. So let's highlight this one in blue. So this entire length will be that red length. So this is this red length. And we're going to add in, let's do orange. So we're going to do this orange length here. So very similar. We know that entire length of BD, because this is BD from here to here, goes from B to D, is equal to that BC plus that CD. So now we have three statements, and we just have to write that last justification here, and we're going to use those three statements to probably substitute. Again, we used substitution a lot yesterday. So notice we have AC, AC, those match. We can take this and replace it. So we're going to replace or substitute. Remember, we did that a lot yesterday. So we know AC's here, AC's here. So we're just taking all of this and replacing that right there, which we're going to write that down as AB plus BC. And that is going to be equal to BD. But we know that BD, right here, again, let's do this in a different color. We know that BD is BD here, so we can just replace all of that with that, which again is that substitution. substitution step. So notice the only real thing you need in here is capital letters and the equal sign. So the only thing we're really using here is adding, subtracting, and equal sign, and then the capital letters. We do not need any of the other symbols at all for this one. Now we're almost done. We're at step 1, 2, 3, 4, and notice, just like before, there's a BC on both sides, so we can actually subtract those to both sides to end up getting A, B, and C, D. So we're going to get those. We have the equal sign, so we just have to subtract to both sides, which is that subtraction. So subtraction, property of equality. Now, these should very much seem similar to everything we do. They'll all be somewhat similar or nuanced. It's just different letters, different things. A lot of it's the same kind of steps. And we'll be adding in more and more of these proofs as we go. So let's try one more example together, example 2. So let's do that. The first thing, again, I like to send the given to the proof. There are 2 given things, so I like just plugging those in. So again, I like to start with those. You don't have to, so I'm going to send those to the proof. So let's just start with there. So we know that measure of angle 1 is equal to measure of angle 3. Again, the reason, well, that is given to us. We know that the next one, after you validate that, is the measure of angle 2 is equal to the measure of angle 4. And again, that is just given to us. That's, if I'm doing a proof by steps, you get 1, 2, 3, 4. I get 4 out of maybe 10 points if there's 10 different steps. Or 4 out of 12 if there's 12 steps. If there's 6 steps, there'd be sides on each side, so there'd be 12 total things. So now let's just think through this. And that's kind of what we have to do with a proof. We have to kind of think logically through this. We know that angle 1 and angle 3 are the same. We know that angle 2 is congruent to angle 4. So we know those 2 things, and we're trying to get that DEF and HGF are the same. So we're trying to say that this angle and this angle are equal, which if those 2 angles, this angle matches that. So if this is 30, 30, this is 40, 40, that's 70, that's 70, that would logically make sense. So think about 30 and 30, 40 and 40, because those are equal or congruent. So if I add them together, which is addition, segment addition, we should get our answer. So let's just start by writing down our angle addition steps. So just think about it. We have the measure of angle DEF. By the way, I kind of have it written down up here as our proof part, so just kind of keep the letters in the same order. So the measure of angle DEF is equal to, well, again, we have this angle addition, this angle here, and we have this angle here, so we're putting those together. So angle 1 plus angle 2. So just write that down. So this is the measure of angle 1 plus the measure of angle 2, and that would be that angle addition. Now what I'm going to do is look at these 3 steps and see what I can do. Now I could write down the angle addition of this side first, which I think I have it written down in my notes that way, but that might be a little bit more work than needed so far. So let's just look at what I can do. Well, I can see that I have measure of angle 1 right here and here, and we know that's the same thing as measure of angle 3. So I can replace it. So if I write down the measure of angle DEF, I can write that as the measure of angle 3 now plus, well, we notice that the measure of angle 2 is the measure of angle 4. So I can replace the measure of angle 2 with the measure of angle 4. So I'm going to substitute that in. So I'm using substitution. So I'm literally replacing angle 1 with angle 3 right here and angle 2 with angle 4. So now I have this step, because if I look, let's go ahead up here and look. We're going to highlight HGF. Notice if I write that down, the measure of measure of angle H. That's not an H. Okay, there it is. HGF is actually broken into two different angles, which is broken into angle 3. So let's write that, measure of angle 3 plus, and it's also broken into the measure of angle 4. So angle addition says this whole angle is angle 3 and 4 together. So we're going to say plus the measure of angle 4, which again, this is that angle addition. Now, I could have done it the step ahead, but it gets in the way kind of. There's a process of stuff you can kind of walk through that makes it a little bit more efficient. So I'm looking at these first three things and doing something, and then I'm looking and, oh, I can bring it in now and do it later. And that also works with the given sometimes. You can prove these a lot of ways, which is very, very interesting. So now we're almost done. Do you notice how those match each other right here? 4 and 4, 3 and 3. And then we have the measure of angle DEF and HGF. Well, we want to get to that. Well, since this is angle 3 and 4, and this is 3 and 4, those are essentially the same thing. I can just take this and substitute it into that. We are going to take and place this right in for those two right here, because it is 3 and 4. So now our last step is just saying our proof step. We're going to send that to the proof. Our measure of angle DEF is in fact equal to the measure of angle HGF. And that is just, again, by substitution. These are fairly difficult and take a long time to practice and learn, hence why you should practice this a lot on your own. You can do Alex over and over again until you kind of understand it. That is the one reason why I really, really like Alex, is it tells you if you're right or wrong right away. Because if you try to validate and it says it's wrong, well, you have to try again until you get it right. Okay, so I would like you to check your understanding on this one. It's very similar to what we did yesterday. We have two segments that are intersecting. We have some given stuff. We're trying to prove that. So pause it. I will have answers very shortly. Just a hint before you do this, I would just write the first given, and we're going to do the second given later. So my hint is write the first given and then do segment addition for both of those, do some substitution, and then use the given. So hopefully you tried it. It is a little bit chaotic to do on your own a lot of times. It's going to take a long time to learn this, and don't be discouraged if you don't get it right away. It might take us the whole year. It might take us this whole chapter. It might take us this whole trimester. It just takes time to walk through it. Again, we're going to do segment addition twice. Again, we're going to take that because CE is this, substituted in. FG is this, substituted in. So we have the statement here. Now bring in our last given. Well, DE and FD are the same, so I'm going to plug it in here. So then I have DE on both sides, and I can subtract it to both sides so it goes away. And we're left with our prove statement. By the way, the last one always should be what we're trying to prove. And that we did that by just subtracting DE to both sides, hence subtraction property of equality. This takes a lot of time, so don't be discouraged if you aren't getting this right away.